Hello, good evening. I welcome you all from wherever you are watching. Welcome to today's video. So without wasting much time, in our previous lesson we agreed to look on something to do with revision. So remember, the revision we are doing is revision of approximation and errors. So after every summary of each and every topic, we will always be doing a revision for various questions. So I don't want to take much time today, but I think the lesson will be long. So I don't want to talk more nonsense rather than to talk the language of mathematics. So let us begin. The first question. Remember, I won't write. I will only be reading. So maybe you could pause the video and you note down each sentence, or maybe play back again. So here we are having our first question. Each side of a regular hexagon measures 8.3 centimeter. What is the maximum? What is the maximum percentage error in calculating the hexagon's perimeter? The question doesn't ask you what is the percentage error. There's a term there. What is the maximum percentage error in calculating the hexagon's perimeter? Now, what is an hexagon? A four-sided figure is called what, guys? Quadrilateral. A five-sided figure, pentagon. Six-sided figure, hexagon. A seven-sided figure, heptagon. Eight is what, guys? Nonagon. Nine. Eight is octagon. 9 is nonagon, 10 is decagon, 11 and decagon, 12 dodecagon. But you'll only be asked the number of sided figure only up to 10-sided figure. The rest maybe you learn in higher institution if you might or may or will continue with mathematics. So hexagon is a six-sided figure. So we are being told, okay, let us arrange that thing, our procedural work. Let us arrange our procedural work. We have the actual, the maximum, and the minimum. The questions are many, so allow me to go fast. So we have 8.3 centimeter. Remember, that one is an individual number. So even if it is an individual number, let's get the accuracy. Accuracy there is 0.1 multiplied by a half. That one is 0.05. 0.05. So we add to get the maximum 8.35. We subtract 8.3 minus 0.05 to get 8.25. I hope you are having your calculator. Just a matter of confirmation. I may make some errors. I may make some errors in the process. Now, remember, they want us to get the maximum percentage error in calculating the hexagon's perimeter. Now, we've seen that hexagon is a six-sided figure. That means to get the perimeter under the column of maximum, we multiply by 6. Or we add until 6. So, but rather take 8.35 by 6 to get what, guys? 50.1. How about on the actual part? On the actual part, we are having 41.5. Oh, sorry. 8.3 by 6. 49.8, sorry. 49.8. That other side, 8.25 multiplied by 6. That one is giving me 49.5. 49.5. Good. Now, after having that, we remember I told you that to get maximum, So long as there's a word maximum, so long as there's a word maximum, you must not get the absolute error. Okay, I want you to understand me, guys. I want you to understand me. Remember, maximum error is given by taking the, okay, let's talk of greatest. So you talk of maximum value minus actual value. This is what will act as our absolute error. This is what will act as our absolute error. Okay? Now, so because the question asks the maximum percentage error, now we shall have our maximum, which is 50.1 minus the actual, which is 49.8. So 50.1 minus 49.8 is 0.3. Now 0.3 is now our absolute error. Are we understanding one another? So this 0.3 is what will act as our absolute error. Do not forget. Do not forget. So when it comes to getting now percentage error, you take the absolute error, which is 0.3, all over the actual value. What was our actual value? 49.8. 49.8 you multiply by 100%. So having that in your calculator, I'm having 0.602409638. Remember to write the whole answer unless the question guides or directs to leave your answer to maybe a significant figure or maybe to a given decimal places. So we are having that. So let's check on another question. The question reads, correct each number in, and we have 527 times, which has been multiplied by 0.18. Now the question reads, correct each number in 527 times 0.18 to one significant figure and approximate the value of 527 times 0.18. Hence, find the percentage error arising from the approximation. Very easy. Remember, I told you how you can use a calculator when you don't know that 527 to one significant figure is giving you what? If any student doesn't understand that 527 to the nearest or to one significant figure is giving us what answer, then I recommend you watch the previous video. Now, 527 to the nearest or to one significant figure, we are getting 500. Remember the question read, correct each number in 527 times 0.18 to one significant figure. So that was it. How about 0.18? We are having 0.2. So we are having the actual. Remember, this type of a question is which category? It is category number 1. And I remember telling me that category number 1 is what? Open approximation and errors. They doesn't require the what? The application of the formula. So you just have to go direct. So we have the actual which is 527 times 0.18. Now just press this in your calculator, 527 times 0.18. And remember, you must first of all come back to normal. So 527 times 0.18, 527 times 0.18. In a calculator, I'm getting 94.86. 94.86. How about the approximated value? Approximated value is what, guys? 500 multiplied by 0.2. 500 multiplied by 0.2. Now 500 multiplied by 0.2 is giving us 100. We are getting 100. So you can calculate the error from the error in between 100 and 94.6, 94.86. So let's have the error. And remember, the error, it is the absolute, which is the actual value minus the approximated value. And remember, they are absoluted. So we have 100, we have the actual value, which is 94.86 minus 100. We shall get we only need the absolute value, which is 5.14. So this is our error. Now to get the percentage error, it is the particular error which we've gotten, 5.14 all over the actual value. And what is our actual value? 94.86. You multiply by 100%. So have that in your calculator, 94.86 times 100. So we are having an error of 5.4185, 491%. 491%. That is that. So let us look at another question. Now the question reads, the top of a dining table has the shape of a regular pentagon. We've just discussed the various number sides of various polygons. Now, the top of a dining table has the shape of a regular pentagon of side 53.5 centimeter. Determine the maximum percentage error in calculating the top's perimeter. Now, remember, there are some key terms there. The maximum percentage error. By seeing this term, maximum percentage error, avoid that direction of getting absolute error in a given number. Avoid that direction. By just seeing the word maximum, you must know that now my absolute error, the way I'll get my absolute error will be different when I'll be getting absolute error when the word maximum is used. So in this point, or in this part, I'll have my maximum value minus the actual value. This is what now represents my absolute error. Good. Now, let us have our arrangement question. We have the actual, we have the maximum column, and the minimum column. So let's start. The question reads, the top of a dining table has the shape of a regular pentagon of side 53.5 centimeter. 53.5 centimeter. So let us So the 53.5 has an accuracy of what? 0.1. Multiplied by a half, I'm getting an absolute error of what? 0.05. So if I add 53.5, I add to get the maximum, I'll have 53.55. Okay? Then if I subtract, I shall have 53.45. 53.45. So having this, now we can get our maximum error. Maximum error. So maximum error is given by maximum value 53.55 minus 53.5. So having 53.55 minus 53.5, we shall get 0.05. Guys, I want you to be that type of a student who does something that he or she is understanding. I know that taking the procedure of 0.1, the accuracy, like for instance, if I were not to follow this route of getting maximum error, having 53.55 minus 53.5, I can still get the same number, that is 0.05, by taking maximum value minus minimum value, then I divide by 2. But are you doing what you know, or are you doing what you are understanding? So it is better to do what you are understanding than doing what you know. Okay, so we have this as our maximum error. We have this. So to get the maximum percentage error, we shall have to get our relative error, which is also the same as fractional error. So it is 0.05 divided by the actual, which is 53.5. 53.5. This one alone is giving us the relative error. But now when we multiply by 100%, we are getting the maximum percentage error. So 0.05 divided by 53.5, you multiply by 100. What are we having, guys? 0.09345 percent. So that is that. Remember, be in a position to do what you understand. Don't do, because okay, the question might be tested in a different way, so that in a way that when you don't understand what you are doing, then you won't be in a position to get the accurate answer. I recommend to go and get a book of Smart Mathematics. That book really has very nice questions which you can revise on and test whether what I am telling you here is right or I'm just making noise. Okay, let us check on another question. The question reads, the base of a right angle triangle was measured as 5.3 centimeter, and its height was measured as 2.8 centimeter. Find the maximum absolute error in the area of the triangle. Now, let's arrange our work. We have the actual, we have the maximum, and we have the minimum. So how do I go about that? Now, under the actual, I have 5.3 and I have 2.8. So remember, I must get the accuracies, and it seems like in this case the accuracies are the same. So 0.1 multiplied by a half, that is 0.05. Now when I add that, I shall get 5.35. Here I shall get 2.85. Now when I subtract here, in this other part, I shall get 5.25, and this other side I shall have 2.75. So how do we get the area of a triangle? How do we get the area of a triangle? It is a half base times height. You don't multiply 5.3 times 2.5. You must apply the real formula of a triangle. So now you'll have a half times base 5.35 times 2.85. So in this other side, we shall have 7.6235. On this other side, a half times 5.3 times 2.8, I shall have 7.42. On this other side, a half times 5.25 times 2.75, I shall have 7.21875. Okay, now, but what does the question want? Maximum absolute error. Maximum absolute error. Remember that word maximum. By just seeing that word maximum, think of the formula. Take maximum value minus the actual value. Okay, guys? So, we are having our maximum value as 7.62375 minus the actual value, which is 7.42, and we shall have our answer as a 7.62375 minus 7.42. We shall have our answer at 0.20375 centimeter. Remember, the units are there, so don't forget to have the units. Square centimeter, 0.20375 square centimeter. So that is that. Let's look at another question. I have a very nice question here. Very nice. Very nice question. Listen. The length and width of a rectangle measured to the nearest 5 millimeter. To the nearest 5 millimeter are 15.7 centimeter and 8.9 centimeter respectively. Find the percentage error in the area of the rectangle. We have the rectangle there. So we have 15.7 centimeter, 8.9 centimeter. Very nice question. We have the actual column, we have the maximum column, and we also have the minimum column. Now, we are being told that the length and width of a rectangle measured to the nearest 5 millimeter are 15.7 centimeter and 8.9 centimeter. Remember, I have told you previously, that when the word to the nearest has appeared in that question, then that particular number is accuracy. It is accuracy. You only need to divide it by 2 to get the absolute error. And that absolute error that you've gotten is what you shall use to arrange the numbers, the given numbers, to their maximum and minimum. You won't use the accuracy of the given numbers. All right. Good if we are understanding one another. So, and remember again, I told you that when to the nearest is used, the units of the nearest measurement, always differ from the units of the other measurements. Like in this case, we are having the units of the nearest 5 millimeter. We have 5 millimeter. Then the units of the other measurement, that is length and width, are given in centimeter. So it is always advisable to convert the units of the nearest number to be the same units as the given measurements, And how do I do that? We all know, you all know that 1 centimeter is equivalent to 10 millimeter. How about the given 5 millimeter? How about 5 millimeter? What is it in centimeter? So you take that 5 millimeter, you multiply it by 1 centimeter, divide by 10 millimeter. So millimeter cancels millimeter. So 5 divided by 10, is giving us 0.5. 0.5 what, guys? 0.5 centimeter. 0.5 centimeter. Remember, this is still accuracy, but it is accuracy in the same units as the other measurement. So 0.5 centimeter. This is accuracy. Accuracy expressed in the same units as the given measurement. So divide it by 2 to get the absolute error, which you shall add in each and every number to get the maximum, subtract in each and every number to get the minimum. So 0.5 divided by 2 is 0.25. 0.25. Now, that is our absolute error. So it is being used in each and every number. So let's start with 15.27, 15.7. Now if I take 15.7 plus 0.25, I will get 15.95. 8.9 plus 0.25, I'll get 9.15. 9.15. If I take 15.7 minus 0.25, I shall get 15.45. 8.9 minus 0.25, I shall get 8.65. 8.65. Let me remove this. Let me delete this. So after having those, remember this a rectangle. So we're gonna multiply. We shall multiply. So we shall multiply 15.95 times 9.15. 15.95 times 9.15, that one is giving us 145.9425. 15.7 times 8.9, I shall get 139.73. 15.45 times 8.65, I shall get 133.6425. So guys, how do I get percentage error? Relative error times 100%. How do I get relative error? Absolute error over actual value. How do I get absolute error? Talk of the maximum value, which is now 145.9425 minus the minimum value 133.6425 divide by 2. Remember, if it were the maximum percentage error, then our work would have been easy. Just take the maximum value minus actual value, then divide by 2, multiply by 100%. But in this case, we don't divide by 2. It is over actual then times 100%. But when it comes to this case, you only take, you get the absolute error, 145.9425 minus 133.6425, then divide by 2. Where we shall get 6.15. That is our absolute error. So let us get the percentage error, which is combined inside the relative error. So relative error is the actual value, the absolute error all over the actual value, which is 139.73. 139.73 then times 100%. Now to get the percentage error, what the question require us to get, so we shall have our answer as 4.401345452%. Remember, the question doesn't specify to what significant figure or to how many decimal places, so it is better to have our answer long in this format, the way it is. Let us check on another example. Let us look on another example. The question reads, a rectangular box has a square base whose side measured to the nearest millimeter is 12.4 centimeter. If its height is exactly 7 centimeter, determine in cubic centimeters the greatest possible error in calculating its volume. Greatest. I told you, and I'm telling you again, that the word greatest, it is the same as maximum. A rectangular box. Something like this. A rectangular box has a square base. So this part is square. The base is square. Measured to the nearest millimeter, which is 12.4. If its height is exactly 7, there's a word exact there used. So let's have our format question. So we have the actual, maximum, and the minimum. So we are having 12.4, and 7. Now there are two terms which an examiner has used in this part once. The first term is use of the word nearest, and the second is use of the word exactly. So exactly has been used where? In the height of the particular box. So that means the maximum will remain the same, the minimum will remain the same. Okay. Now to the nearest millimeter, that is the same as to the nearest 1 millimeter. Make sure you understand what you're doing. Don't be confused and now you start to get the accuracy of 12.4 and 12.4. I know that one will still give you the right answer. I know. But now just be someone who understands and know whatever he or she is doing is right. But I know that is a simpler way of maybe you can maneuver that way when you understand what you are doing. After knowing that 1 millimeter, when I convert it to centimeter, it will be still the same thing when using the accuracy of 12.5 and 12.4. But for you, the person whom still maybe, let me say, you don't understand, don't have that way. So let's convert 1 millimeter to centimeter. We know very well that 1 centimeter equals to 10 millimeter. 10 millimeter. 10 millimeter. What about 1 millimeter? So that is 1 times 1 divided by 10, giving us 0.1 centimeter. So this is accuracy in the same unit as the given measurement. So take that accuracy, divide by 2. Divide by 2 is 0.05. So add it. 12.45, 12.45. So when I subtract, I shall have 12.35, 12.35. And remember, the question wants us to get the volume. Volume is the same as multiplication. So length times width times height. So 12.45 squared times 7. I shall get 1085.0175. On this other side, 12.4 squared multiplied by 7 shall get 1076.32. I shall have on this other side 12.35 squared multiplied by 7, having 1067.6575. And by the way, I'm sorry, the examiner used three terms at once in this question, whereby number 1 was the nearest, number 2 is the use of the word exactly, and number 3 use of the word greatest, which is the same as maximum. So but examiner just want us to get the greatest possible error. That is the same as asking you to get the maximum absolute error or the greatest absolute error or the greatest absolute error. So maximum possible error, maximum error or the greatest error, you talk of the maximum value 1085.0175 minus the actual value, which is 1076.32. So let's have that in your calculator. 1085.0175 minus 1076.32. What are we having as our answer? 8.6975. 8.6975 cubic centimeter. Remember to have the units. With your answer. Let us check at another example. So this is the last example which we are doing, and so the rest you will have to find the time and do more revision. But still, what I've done with you is not that much enough. I know it is enough, but it is not that much as expected. So the question reads, the time taken by an object to cover a distance approximately 23.5 meters was recorded as 1.8 seconds. Find the percentage error in its average speed. And that is why I told you, this question is very nice. I told you that an examiner will not just give you a direct question that this part is multiply. Okay, an examiner won't use such words like directly, multiply, add, divide, subtract. An examiner won't use them directly. They'll come in form of a hidden formula somewhere, whereby you will have to think, like in this case, if what am I supposed to get? Will it lead me through multiplication, division, addition, subtraction? You must reason. So let me read the question once again. The time taken by an object to cover a distance. We have a distance approximately 23 1.5 meters was recorded as 1.8 seconds. We have time 1.8 seconds. There's a formula in a triangle I used a lot when it comes to solving this thing. DST. So D stands for distance, S for speed, T for time. And the question asks, find the percentage error in its average speed. So an examiner wants you to get the speed in terms of getting the percentage error. So arrange your work. So we have the actual, maximum, and minimum. So under the actual, I have 23.5 meters, 1.8 seconds. So I'll get their maximums. So under the distance column or side, I have an accuracy of 0.1. All of them, they are having an accuracy of 0.1. So that 0.1 you multiply by a half, you get to get 0.05. So you add 23.5 plus that 0.05 shall get that. And on this one, we shall get 1.85. On the minimum side, we have 23.45, and 1.8 minus 0.05, we are having 1.75. Now remember, this is distance, this is speed. Oh, sorry, this is time. So how do I get speed? Speed is given by distance divided by time. So we are dividing. And remember, I told you that subtraction goes hand in hand with addition. Subtraction goes hand in hand with division. Addition goes hand in hand with multiplication. And we agreed that, or we said that, their procedure for those two pairs are different. The procedure which I'll use to get the absolute errors of addition and multiplication will differ from that procedure that I will use to get the absolute error of what? Of division and subtraction. So they differ. So in this case, to divide, let's start to get the maximum column. So you draw a line from that top part to the bottom part, then you divide. So having calculator, we have 23.55 divide by 1.75 to get the maximum column. Just write the whole number, no matter how long it is. So here we have 13.457 286. Under the minimum, the same. You start from the top all the way to the bottom part. And what do? We divide. It is not necessary to write divide as long as you understand what you are doing, but again, it's just a tip I'm giving out. So 23.45 divided by 1.85. So what are we getting in that minimum column? We have 12.675675 0.568. And at the actual, you just divide the way it is. 23.5 divided by 1.8. So we are having 13.0. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And with the 6. After having that, the question wants us to find the percentage error. So percentage error, we first of all, let's get the absolute error. Let us get the absolute error. So the absolute error is given by taking maximum value 13.45714,286 minus the minimum value 12.67567,568 divide by 2. So have that in your calculator. 13.45714,286 minus 12.675 6767568, then divide by 2. I'll get my absolute error as 0.3907359. So to get my percentage error, it is this absolute error all over the actual value, and the actual value is 13.0. 1, 2, 3, 4, 5, 6, then 6. So percentage error is absolute error all over actual value, then you multiply by 100%. So have that in your calculator, that numerator all over denominator. 1, 2, 3, 4, 5, 6, 6. Then multiply by 100. So our answer will be 2.992853029%. Remember to write the whole answer the way it is, unless the question guides or specify to leave your answer to maybe a given decimal places or maybe a given significant figure. So we've come to the end of our topic, approximation and errors. I want to believe all is well and you are gaining something at the end of the day. I only wish you good luck in your studies. But remember to share knowledge. Remember to help one another, because at the end of the day, that is what shall define you. You can be a brave student, but whenever you are not sharing the knowledge you have, maybe because of jealousy, because of uncertain fear of being defeated, my friend, I want to remind you that at the end of the day, you will be the one drowning, but not the people that you are thinking that are drowning. So, God does work in different ways that you can't understand. So make sure you help one another. The main reason why I'm telling you that I am a victim, and I may not wish to see you suffering in the same problem. Wanasema kwa Kiswahili, usimwache mbachao kwa swala upitao, na ndio maana nawaonya mapema. It's alright. I thank you all for watching. Thank you so much. You mean a lot when you subscribe to my channel and you comment. I like it. I love all your responses. Thank you, and thank you very, very much. Let us meet in the next topic. Maybe if you have your own topic which you feel like it's urgently I must do before you go back to the school, it's well okay. You can have it there in the comment section. I'll check. But for today, I thank you very much and may God bless you all. Thank you.